register yourself for these particular sessions on that. So, and thanks to Saurabh sir to giving his time to arrange once again the train the trainer kind of programs. So, as you know, for the digital literacy program is going on. It is not only for India; it is across the globe. It is going on. We are moving towards the digital age going forward, right? So, to make yourself digital, though these robotics, AI, and all those stuffs are very much important for today's education perspective. That is the reason behind STEAM is introduced in the curriculum for across all the board in across the globe over there. Right? So we ex robotics, we are working almost last 7 8 years in this particular field, and we are helping teachers to train them in this particular technology so that they can able to deliver to the teaching to our kids over there. So that is the reason behind we have arranged multiple times the train the general kind of programs. So this is the once again we have arranged this program. This is a 24 total package is 24 classes we used to conduct, and the entire package we have you will get the in the kit, you will get the digital books, that is a LMS systems, learning management systems, your certifications, 1 year free support, everything is there to make it easier for you. This time so we have started with the 4 classes free of cost, so you can able to understand, you can able to do a lots of hands-on things, and we will give a share all our LMS access as well. Okay, so it will be easier for you to take a call and see how we are teaching, or how we are helping the teacher fraternity to for this particular digital literacy journey. Okay, I will uh, I will wish everyone should take advantage on these particular sessions. So over to you, Saurabh sir, to take it forward.
Yeah, sir. Thank you so much, sir, for the opportunity today. And welcome. I welcome each and every teachers and mentors, educators from the Pan India region as well as from outside region to this session, so that we can come up to the conclusion where how to like begin in this particular process for STEM and AI journey in your classroom program, in the school itself, right? So everyone are interested to know about the details, how they can start and how they can cope up with the syllabus the board member already published recently. And also from next year onwards, this particular thing is going to be compulsory in each and every school. So even though the state boards nowadays implementing the STEM AI concept. So in overall terms, we can see the broad spectrum of like the opportunities for the teachers, mentors to further evolve in the process. The time when we started our journey in the like the technological part itself, we started learning the computers, and we initiated our learning through the different applications like MS Word and everything. But right now, the demand of our society is to bring something new, like something innovation oriented stuff into the classroom program, so that our student will learn the concept in easy manner using the practical approach. As we know, maybe you already heard from different type of YouTube videos and other platform stuff, that the people learn more if they are like involved in the process of seeing the pictures like visually, as well as they are getting more in contact by hearing out these stuff from the teachers, right? So earlier, the conventional method of we're utilizing in the process is
Yeah.
reading a book, and further reading a book, and then okay, I'm muting your.
Okay. Yes, got it now.
Yeah,
That star is in double quotes. So that is what you get as 20 into symbol and 23 you get.
Padma ma'am, I request you to kindly mute yourself so that I can further continue with the same. Okay, thank you so much. So where we are. So as I mentioned earlier, that in the time, this is the right time to start learning this STEM concept before proceeding to the classroom program. So allow me to share my screen. And first of all, I would like to share the agenda of today's classroom program. And further, we will get into, we will dive into broader sense in which we will explore the technological part. We will see different microcontrollers we can utilize in our classroom program to like explain the concept of the theoretical portion mentioned by the board members. Even though like the ICSE board members like wonderfully came up with the ideas, as well as the CBSE board members came up with the ideas to implement these. Because in early times, what we used to have is a conventional classroom program in which students were learning this stuff by reading, reciting, and finally giving the examination upon memorizing stuffs in the textbook, available in the textbooks. But right now, the things are changed. Things are changed. How the things are changed? We are trying to do those stuff practically. Earlier, the approach to have a practical in different subject was not available, right? So science, in terms of science, we do have different practical, and even though the labs are available in different schools to do the various experiments, for example, the photosynthesis type of lenses and various experiment related to science is already available. But why is there a need of STEM? Because it helps a student to understand the concept practically by doing those things. Suppose we have to calculate the distance, then they will go through the mathematical concept, they will build out some of the projects, and they will implement it directly in their classroom program, right? So in this whole session, like 24 session, why to have the 24 session? The first and foremost question will come from each and every teacher side, right? And second, the what we are going to cover in these code free classes for you teachers out there. So in 24 classes, there is a glance and each and everything is included, like the syllabus part. And apart from the syllabus part, we do have a specific range of coverage for different platforms. And by the term platform, I meant the open source platform. And open source platform, why to go for the open source platform rather than being dependent on the software and other solutions available in the market? Because open source platform will give you the ability to like develop and share with other person around the world, right? And by the name itself, the open source platform means it is free for each and every educator, mentors, and students around the world, so they can utilize the tools which are freely available into the internet. And we will take it as a positive side of internet and utilize the same to develop different projects throughout. So in this fourth session, what I'm going to cover is I will start with the day one today. And in day one, I believe some of you already joined my earlier classes. So basically, they know the introductory part, the law of robotics, the analog systems and digital system. We will discuss the analog system and digital system in details, as well as we'll have an introduction to basic robotics for a student. Because the time when you learn these things by yourself, it will be completely different compared to the lecture you will deliver in your classroom program, because students are not that much aware of their technologies, of different technology present in the market, as well as they don't know much about the programming languages. So we must cope up with the idea in which we are going to address the students in front of us, right? So whatever the teachers are going to learn will be completely different from the students, because a student needs a simpler word to understand things, and a student will learn this stuff by doing it practically. But as a teacher, or from the teacher point of view, we can say that you have to go through a lot, means you have to cover more than the student itself. Then only you will come up to the conclusion
Thank you. Thank you.
where you will solve the problem. So we will discuss the basic component to build the robotic system, as well, like the hardware and the software devices required for this development. And maybe you already have the idea about different hardwares available in the market, like the boards, the development boards, microcontrollers, and so many other stuff. And further, we will discuss type of robots present, which directly came from the syllabus itself, and we'll discuss it in details. And from day 2, day 3, and day 4, okay, at the end of this session, I will help you with some of the components name, so that you can gather those components by yourself from the market or nearby stores available, so that day 2, day 3, and day 4 will be helpful and useful for you guys. Because in day 2, day 3, day 4, we will go completely on practical projects. We will learn the aspect of programming, and we will do those experiments directly on a live this live meeting. So what I'm going to start with the introduction of robotics and STEM. So this is all covered in the LMS portal, and after this meeting you will receive the notification in which the credential for the LMS will be provided to each and every teacher. So you don't have to worry about anything, even though some of the point I will skip, because going through the theoretical content, I believe you will not feel good in this term, because as a normal person we cannot able to digest much of the theoretical content compared to the practical one. So I will limit myself to the amount which will be suitable for you teachers out there to understand the concept, and further we will move into the practical orientation. If from the teacher side, if you do have Arduino boards, Arduino microcontroller, or the board itself like Arduino Nano, Uno, and other models, then please be ready with those things, because before the end of the session, I will show you some live example of projects, and also will demonstrate some of the cool insights and ideas to develop different projects related to the syllabus you are going to deliver in your classroom program. So in simple terms, before proceeding to the STEM concept, robotics concept, let me ask you one question. The STEM itself. So we always heard this term, even though because of the STEM only you all joined this session, right? So what does it means? Does it exactly means to us, as well as what the impacts of the STEM to the students we are going to see. So STEM signifies four domains, specifically the science, technology, engineering, and mathematics. And we will know about these domains, but in some of the countries, we can see there are five domains. That is STEAM, STEAM. Means we are not limiting ourselves to science, technology, engineering, and mathematics, but also we are including the arts into it. And why to include arts? Because through the idea of arts we can come up with our creativity. Suppose if we have to design a bridge which can sustain like 1 kilograms or 2 kilograms of load. I'm talking about the prototype one, not the actual model which can take up to the load of 1,000 of tons or something like that. So if we have to design those, then your creativity will play a vital role developing those type of concept and solving those type of problems in your schools. So STEM signifies the concept including the science, technology, engineering, and mathematics in our syllabus. But why these? Because science and mathematics is already being taught in our classroom program. So why exactly these four terms are all together? You have to understand this. The reason why, because science gives us the ability to understand more about our environment, right? And technology helps us to achieve those things, as well as the engineering perspective, or an engineer is responsible to build those technology for us to utilize, right? In simple terms, engineering person or any department of engineering branch helping us to make our life more easier compared to the conventional stuff. And why to have the mathematics? Because we cannot able to imagine our life without using mathematics in a simple day-to-day life, or we can say in a normal life we utilize mathematics in a common, right? So mathematics gives us the ability to do the calculation, to keep the count of different object, to define the object uh, with some of the dimensions, like the physical dimensions. Suppose if you have to explain some sizes of different object in front of you, then you should use the length, width, and height concept to explain the same. So similarly, mathematics is integral, what we can say, integral part of this whole chapter. And through STEM we are actually helping students to build their problem solving skill, and also increase their creativity to help serve the society. And if we can help our student to solve the problem happening in their society, means we are actually solving the problem of this world. And by the term I use solving the problem of this world, I mean we should address, as a human being we should address different problems in our society. We can come up to the conclusion where we can achieve those problem solving skills by doing it practically. So why the robotics education came into existence, if we are talking about this STEM only? Because Robotics, actually, we are utilizing robotics as a tool to help students understand the concept of STEM. So we are helping them build different projects related to the STEM. And even though like the car, the remote control car, maybe you already seen over YouTube, and the IoT enabled car, and some of the cool project like the smart dustbin, and so many other stuff like drone itself. So those things does require a mathematical calculation. Suppose if you are building a drone, then you need to calculate exact thrust to lift that drone, as well as to generate those thrust, we need to have a proper calculation for RPMs of different propellers, right? So RPM signifies the speed of propeller in which the propeller will achieve the circular motion, and also it will produce the thrust to lift the drone. So those things requires a in-depth knowledge of mathematics, even though the basic knowledge will help you further build the uh, general portfolio in this domain. So what is exactly the robotics? What is robotics, and what is robot actually we are talking about? So we can say that robotics is a branch of technology and engineering that focuses on creating machines called robots, right? So even though, and why we need the robots, and what is the definition of robots? Robots is a combination of mechanism in through which we are helping a human being to accomplish certain tasks, right? So robot is actually helping us to achieve those tasks in those places where a human beings are unable to like go complete the task in time, or even though to complete to achieve any of the lead points. So by the term the environment, if we talk in terms of environment, like the toxic environment, suppose if we have to conduct a research inside the volcano, or if we have to explore the space, then we cannot able to achieve that without any protective suits or any other stuff like the rocketry system itself. So we can call it as a mechanism build, or mechanism based something like machine itself to help us accomplish certain tasks, right? So they are obviously made up of different parts like sensors, motors, brain, and other devices, right? Which helps them think, and also which helps them to make decisions based on the input coming from the environment. So we've seen several examples in our society where the robotics being employed. Suppose if I ask you to like do a task on a regular basis without like taking a break, or without like leaving it for a minute, then what will happen to a human being? Human beings are not entitled or not capable enough to do the repetitive task. On that place also we need robotics. And if I give you one example to understand this concept, then you can take an example of industrial automation, where the car and different vehicles getting assembled on a daily basis, and humans are not that much of capable to resist the repetitive action. So that is why in assembly line in factories we must employ the robotics functionality, or robotics automation is stuff to accomplish those things. So if I dive deep into the concept of robot and robotics, you will find it funny because the word robot has an interesting origin. It actually comes from a play called RUR, Rossum's Universal Robots, written by Czech playwright Karel Čapek in 1920, in which he demonstrated a robot depicting as artificial human beings, human-like beings or human beings that were created to serve humans. So the robot itself is derived from the Czech word robota, which means forced labor or work. In the play, the robot were created to work for human and perform tasks that were difficult or dangerous. Over time, the robot became popularized and adopted in various languages to refer to mechanical or electronic devices. And by the term mechanical or electronic devices, if we combine these two terms in engineering, mechanical and electronic, we will find one interesting terms, that is mechatronics. Mechatronics means we are talking about mechanical body which is getting operated by electronic stuff. But in between, what we need a thing to control all the aspects like the input as well as the outputs. That is why we combinedly call it as a robot or robotic system, in which mechanical part performs the motion producing events, and also the electronic parts which are controlling or actuating, helping the mechanical helping the mechanical parts to actuate or produce the locomotion. And apart from these two, what we need to have is the programming part, through which we will program the entire robot, and further the robot will perform its duty. Okay, so importance, why we need to have STEM education. You can see this chart in here. So it helps to improve decision making among the students as well as for us. It is very much important. It enhances the problem solving ability, and it refines your research skill. Means if you have to build one of the robot which are not present in the market itself, then you have to go through the Google and go through the content of different people who are already worked on that domain, right? So what we are actually doing is to research, we are researching on that particular domain to find out our answers, uh, the place we were stuck in, right? And also it polishes your creativity. Means if you come up with the ideas where you started developing a bot or something like that, means you will see sometime some of the problem will occur in between. So you will attach something, or you will include some of the new components as well. Suppose if you're building any IoT enabled car or something like that, the person will demonstrated the suppose you are watching a YouTube video or something like that, and a person demonstrated to utilize a gear in between, but in your place you will not find the gears or other devices. Then what you will do, you will come up with the alternative of that gears, right? You will come up with building one of the gear by designing it on a different platform and printing it using the 3D printer, or something else. Like you will find a cardboard in through which you are going to like build that mechanism or something like that. So it will help you polish your creativity, and also it will stimulate the curiosity, because we are going through the programming part, and programming part does require a logic to perform it in it, right? So it will help you further to stimulate your curiosity. So fostering the critical thinking and problem solving skill is the major key ingredient in this STEM education. So you can see further what we can do is to help the students to improve their creativity and innovation. And by the term innovation, in X robotics, what we say always to our students and our mentors, that we should focus on the basic component of robotics whenever we are going to build any of the robotics. Because if we get dependent on DIY stuff like the Lego blocks and other things like the other peoples are implementing nowadays to teach the robotics in their school, then what will happen? You will stuck in between the time when you will develop a new project from scratch. So you have to understand the concept of basic robotics, as well as you have to learn the concept of basic electronics. Like I'm not talking about the hi-fi electronics in which you have to design the microcontroller or microprocessor, but you must know the common concept of electronics, like positive and negative terminals, configuration of different pins in microcontroller, as well as the different electronic components like resistor, diodes, and transistor, and etc. So before proceeding to the exact project development today, I would like to I'd like to get your focus on law for robotics, because you must take care of ethical consideration while developing this robotic system, because ethical consideration helps us to utilize the science or any of the technology in a positive sense. We do not want our children's or the students to get involved in a series of that negative part of these science, right? So what are the three laws? And also the three laws also came from the same origin, where the plays came into to define the robotics itself. So Asimov actually gave this concept. Asimov's actually the science fiction writer as Isaac Asimov gave the three laws of robotics in his stories and novels, and that were designed actually to prevent disaster in between. So first law states that the robot may not injure a human being, or through inaction allow a human being to come to harm. Means if you are building any of the robotic system or any of the devices which are going to help serve in society and also to solve some of the problem in society, may not should not harm human beings, in between, right? This particular law emphasizes the importance of preserving human safety and well-being. It requires robot to prioritize the protection of humans and prevent any action that may cause harm to them. And also, the second law states that a robot must obey the orders given to it by human beings. Okay, except where such orders would conflict with the first law. Means whenever I will ask my robot to like perform particular task for me, like if I ask my robot to like bring a glass of water for me, then it should follow my orders, but it should not follow my orders if I ask my robot to like harm any other human being in front of it. So it should not contradict with the first law, and it stays as it is. So it will obey your orders, but in that case where human harm comes in between, then it should not follow the same. So let's go for the third law. And third law says that a robot must protect its own existence as long as such protection does not conflict with the first law or the third law. Means, suppose if we sent one of the robotic system to Mars or any other planet, and somehow our robot came into the like collision, or something happened to our robot in which robot harmed itself, right? And some of the parts were not working, and the parts are need to be replaced. So as a human being, we cannot able to reach. Yes, we already reached to different planets like the Mars and other, but we are not in that much position where we can exactly go to that planet and fix our robots, right? That is why we need robotics to like help us explore different planets and different part of solar system. That is why I mentioned the term robot means to us that it is helping us to reduce our effort in different sense, right? So that on that particular place where we are unable to reach, we must allow our robot to to help preserve the things, like to help fix the things, and through that we can ensure their own survival. But robots should not violate the first and second law in between, and it should always follow the concept of first and second law, but keeping in mind where where we are unable to like repair the robots in time, we can utilize the same to help the robot like protect its own existence by repairing itself. Okay, this is all about the three law of robotics. And yes, obviously, we've seen several examples in our society where there is implication and limitations of the law. So yes, there is a limitation of the law. Suppose if I talk in terms of the harming a human being or something like that, then then how we can able to define those terms to a robotic system, because we are the one programming it inside of the robotic system, right? So this particular word means different to different persons. For example, if I ask like a mother like is scolding his boy or his son or like daughter in front of the parents or something like that, then we should not consider that as a harm, right? Because it's a general procedure followed in different homes. But if we follow the other protocols like harming other human beings by means of force, or like giving them the like cut mark or something like that, then it should be counted as limitations of the law of robotics in terms of the word harm itself. So we should build our ethical framework through which we have to work, and also we have to come up with the ideas where we can further improve this complete system, this entire system. So let's discuss the analog system and digital system first before moving into the robotics chapter. So as you all know, maybe you already heard of these systems before, and analog system and digital system is very much important for us to know before proceeding into the robotics, because it allows us to understand the concept in easier way, and also it helps us to do the programming part later on. So by the term analog system and digital system, I only meant about the values. So suppose if we have to talk about the digital system, then what we should consider, the digital system composed of two values, that is 0 and 1s. Means we are talking about some of the off condition and one of the on condition. So whenever we take these two into consideration, it will be called under digital system. So those things like the camera itself, mobile phone works on a digital system. But earlier, in past times, we've seen some of the examples like the telephones, and even though the copy and notebooks were preferred to be called as analog system, because in analog system we are talking about the range between the values, the range between which values, 0 to 1. So analog system is nothing but a range between two values, that is 0 and 1. So suppose if we are driving a car at high speed, like the autonomous car, I'm talking about the autonomous car because there are two aspects of robotics we should consider in our classroom program. One is the manual robotics, and second one is the autonomous robotics. So why we should consider these two terms? Because manual robotics means, or manual, if I take the example of car itself, which you are driving, or any vehicles you are driving, then it does have the manual configuration to control, right? The steering itself, brake pedals and acceleration, everything is there, which you should control manually. But in autonomous car system or autonomous robotics, we are controlling those parameters based on the inputs coming from the sensors and other devices. And further, the brain is responsible to process that data, and the motion will be controlled using the motors and everything. So in between, we do need those two systems to control the aspect. Because suppose if we are driving a car autonomously and we asked our robotic system to uh, pick pick us up from point A and drop us at point B, then what will happen? The car will start driving. So if we follow the digital system, then what it will do, it will turn on and off the propulsion system. Turn on and off propulsion system means, okay, turning off and on propulsion system means we are turning on the motor, turning the motor on or off. So we are not actually controlling the speed, but we are just executing the task to like turn on and off the device. But using the analog system gives us the ability to control different parameters like the speed itself. So we can give them the output of 0.2 or 0.5 according to the need of speed is required for that particular movement. So 0.5 will signify the half speed. If we supply 1 through the programming, then we are talking about the full speed of car. So similarly, we need to have these two systems into consideration through which we can develop different robotics counterpart. So, okay, let me move down in this chapter so that it will be easier for me to explain the system in detail. So you can see some of the examples of analog and digital system are properly mentioned in this portal. That is, if we talk about the analog system, we often go through such examples in our day-to-day life. That is the watch itself or wall clock, and different voltmeter and other things accommodated inside the stabilizer and inverter in our home can also be seen as the analog system. Even though the joystick through which you place the game using the game console and everything, it does have the analog type of output because we can control the exact parameters. So the time when we have to control the exact parameters, we should utilize the analog system in between. And the time where we are just responsible to turn on and off the device, then we should follow the digital system. And the examples of digital system are the digital clocks as well as the digital multimeters. And multimeter is one of the device through which we measures different equipments, different components of electronics like the resistor, diodes, transistor, and so many other devices. Even though we can able to take the readings of voltage present and also the amperage present. So because if we talk in term of electricity, we should consider three of the things in total: V, I, and R. Voltage and current, as well as the resistance of those things. So I will discuss those in details for you guys to understand. For now, I'm just giving you the example to just simply understand the things so that we can proceed further. Even though some of the push button are there in your mobile phone on the right hand side and left hand side to control the volume as well as to lock the screen. Those are the digital system through which we are producing the two values. The time when we are not pressing the button, it is actually producing 0, and the time when we are pressing this particular button, then it is producing 1. So our microcontroller or the brain of robotic system will understand that something is happening, and we are receiving two of the signals, 0 and 1, so it will act accordingly. So these are the example of digital system. Let me move back to the other system as well. So suppose if you have to explain the concept of robotics to your student, then the simpler words you should use in your classroom program will help them understand the concept very easily and in very precise matter. So robots have, you can call the same definition from the earlier chapter. The word robot itself derived from the Czech word robota, which means drudgery. Drudgery means a robot can be defined as a machine operated by computer programs that can perform small actions to help us accomplish the task in such an environment where human beings are unable to perform the task and its duty. So the field in which we study robots is known as robotics. And we can call the simple terms by addressing these 5 things in total. So those things, robots can be defined in terms of powered by electricity, programmed to carry out certain tasks like cleaning, etc., and sense the environment using sensors and react accordingly on its own. And it helps human being to carry out repetitive tasks and can work in hazardous and toxic environment. And it helps us to explore places where a human being cannot able to reach or find difficulties to work on. So if we take the similarities between if we consider the similarities between robotics body and the human being itself, then we can call a simple stuff we often go throughout our day. Like whenever we see something or whenever we feel something, we are, what we are doing, we are sensing the outside world, right? We are sensing our environment through our sensory vision and different sensory organs. Like the eye gives us the visual perception, as well as ear help us to hear out the sound waves coming from the outside world. So robot does have the same similarities. Robot does have the similarities of human being as well, because we human often copy the things from the nature itself. So we try to replicate ourselves, but we are not allowing those robotics body to become intelligent as we are nowadays. Because if it will happen, then what we see, the new era of AI, like many artificial intelligence stuff is already in place. Like we can see there are varieties of tools present in the internet to help you reduce your day-to-day task, right? And it helps you to reduce the efforts to do those certain tasks. Like even though if you need to write something, you just have to ask chat gpt about the same, and it will give you a complete paragraph. So those examples are actually helping human beings, but we do not want those examples to further evolve to become Terminator kind of stuff, so which will destroy our world, because humans are unpredictable in every sense, and also we are fighting with each other, having wars and something like that. So robot will try to wipe out the humanity if we give them the ability to think and act on their own. So we must follow the consideration, we follow the laws of robotics while developing anything in between. So similar to human beings, robot does have the sensing capability. Further, it does have the perception and the cognition ability. And by the term cognition ability, I am only mentioning the brain capability of our brain, right? Through the brain, we can uh, actually come up to the idea where we can decide what to do and what not to do, right? So cognition ability helps us to decide certain things. Suppose if you are going to cross the road and any vehicle approaching from the other side, then we should stop ourselves uh, to not get into the accident or something like that. So cognition ability is all about the programming part done in the microcontroller or in the brain of robotics. We call it the brain of robotics in our junior students, because student often confuses by the term microcontroller and everything. So we must take care of these things in our classroom program for them to understand the concept in an easy manner. compared to us. We as a evolved person or as a teacher, we can digest anything given to us, right? We can go through the articles, we can find the typical sorry, we can find typical technological terms, and we can actually come up to the idea where we can understand those terms in easy manner. So we should not force them to learn those concepts. We will always come up with the conclusion where we are delivering the word simpler to them. So action ability is all about the locomotion and actuation system in robotics, similar to beings. As a human beings, we do have our hands, legs, and other things to like produce the motion, like even though the body is responsible to produce the motion. So in robotics, we do have different pairs of motors, actuators, and the vibratory part to produce those motions. So according to our needs and requirements, suppose if we are developing any amphibious robot, so we must take care of the water contact with the electronic parts, and also we should consider the propeller in place of wheels and other stuff, because wheels will help us achieve the motion in the ground itself, but propellers will help us to achieve the motion in water or any fluid medium, right? So the action will be generated by different output devices available for in the field of robotics. So if we take the examples, I always encourage and always like encourage our teachers and mentors to come up with the natural examples. Natural examples means those examples which are readily available in the market itself. So students have the idea about nowadays, because they are going through the different social media platforms, and they are obviously utilizing the mobile devices and internet in between. So they do have knowledge about the autonomous car, the SpaceX, Elon Musk, and everyone else, right? So in our classroom program, we must focus on those simple examples which we can throw in front of the students for them to understand the concept in easier manner. So if I take the example of a robotics body, the driverless car will be a perfect fit for the same. So it does have the video camera, rotating sensor, radar sensor, and position estimator, which helps the car to exactly map out the location nearby. So it map out the location nearby, it identifies the pedestrian, and also the video camera is used to monitor the traffic lights. So suppose there is a red light in the traffic, then what will happen? The robot, this video camera will take that reading and send it directly to the brain itself, and brain further will decide what to do. And the brain placed inside the car will decide the car to stop in between, because if it won't stop, then the accident might occur, might happen. So we must take the consideration of these natural examples which are readily available in the internet and all, for our student to learn the concept. So the rotating sensor itself in this, and radar sensor in this particular example, used to estimate the surrounding area, like what type of car is approaching from the back side, from the left side or the right side. And also it will like make one complete map, a 3D map of car's environment, so that car can decide further and go for the same. So cognition ability is about the algorithm. I already mentioned the same. The algorithm, we will place that inside the car. So the algorithm means if it sees the red light or green light or yellow light, then it will act accordingly. So to avoid the obstacles in front of it, and to reach to their goals. And action can be controlled in this car using the motors and actuation system. So actually through the concept of STEM, we are not only giving them the example to understand the robotics and robots part, but also we are integrating different terms in our examples. For example, the vehicle, this particular vehicle itself is producing, the wheels of this particular vehicle is producing the circular motion, but we are not actually rotating along with the wheel, right? We are actually moving in a linear direction. So through this concept, we can explain the translatory motion. So means we are actually translating one type of motion into another to achieve our goal in between. So mechanism and different things are also very crucial for the students to understand. Then only they will get the best out of the STEM and robotics classes. So different components, like the basic components of robotics. We can call it as a combination of different things integrated into the robotic system. So for example, if you have to explain the body part itself, then you can give them the similarity of a skeleton, which signifies to help us like accommodate every organ inside of our body, right? And without the skeleton, our body will be a soft sack. Soft sack means it does not have the rigidity and shape that defines it. So the only difference between the robot and us is that is not exactly a sponge sack. So in case of robots, we often use the term, we must use the term chassis in front of the student for them to understand the outer structure of robots can be addressed using this particular word. So after the chassis or the body part, what we do have is the sensor. As I mentioned earlier, one of the term, the robotics system or the robots itself does require three things to function properly. What are those three things? First thing is the input device, similar to our computer system. Second thing is our processing unit, similar to our computer system as well. And third thing is the output device. So in terms of robotics, what we call the input device as sensors. And sensors are responsible to take the readings from the environment, and further, it will send those readings coming from the environment to the processing unit of the brain of robotic system, decide what to do and what not to do, what to do and what not to do. So processing system is nothing but microcontroller in the robotics body, which we will see some of the examples today, and we will do one live exam, live practical for the same to understand the concept of how different sensor works and how we can integrate those things to our microcontroller to make it functional. So output device is nothing but a device which are responsible to produce locomotion and actuation in robotics body, and it is not limited to actually locomotion and actuation. If we talk in terms of the output device, we do have different varieties of component to produce the output in robotics body. For example, apart from the locomotion and actuation, what we do have is the led, and led is responsible to generate light signal or light wave to alert the user in front of it, right? So this will be one of the other systems apart from the locomotion and actuation. And apart from these, what we do have is the speakers. Speakers or the buzzer modules or buzzer system to produce the sound waves, and further sound wave will also help the human in front of it to understand different condition of the functions we are implemented in our robotics body, to alert the user whether something is going wrong in front of it, and also to generate some of the signals to help human being understand the problem or any other aspect happening in the robotics body itself. So let's take one of the example to completely understand the concept of sensor first, then we will move into the microcontroller or the brain of robotic system, and further we will explore the concept of output devices, and after the completion of output devices we will move directly into the practical part of this class today. So if I take examples of human body, then we can see different organs are there in our body, right? So for visual recognition or the visual perception, we do have our eyes with us, which help us see the environment and come up to the conclusion where something is present in front of us or not. So even though to identify different object in front of us, we need our eyes to be functional, right? So in robotics body, we do have CMOS sensors, and along you can see the CMOS sensor is properly mentioned in here, and in different cameras is inside of different cameras, actually this CMOS sensor is present. So along with the CMOS sensor for sight recognition, and one more thing is there is the focus, because focus and sight are two different aspects in our body, and focus can be controlled using the retina and lens present in the body, right? In the eye itself. So if we combine these two, the sight and focus in the robotics body, we call that thing as complete camera. right? Camera is composed of both of the things, the focus system and the sight capability, which is coming from the CMOS image sensor. So it helps us to identify different object in front of it. And many of the models like the ITMS model, maybe you already seen those models implemented in the traffic light system. One camera is there in each and every traffic light signal to identify the rule breakers. Rule breakers means those person who are not wearing seat belts and not wearing the helmet while driving the car and bike. So the camera itself will help us identify the culprit in between. So how it works? So camera takes the visual reading from the environment, and further it sends the video to the algorithm based computer system in which the data is being processed. Like if we talk in terms of Python programming, we do have OpenCV scripts, is OpenCV algorithm for the same to like go for the OCR scanners or optical character recognitions and other things. So through those algorithms, we can actually come up to the conclusion where we are identifying the culprit. So it is solving one of the problems, and those systems are not implemented to like give you the challan or something like that. They will not give you some of the problems in your life. It is only implemented to save your life, because people often tries to break the rule in between, right? they the government itself help us to like implement those systems because they do not want any major accidents. So that is why the system is being implemented in our daily life. So body balance can be achieved with one of the gland available on the backside of the brain. And I love to hear the answer from you teachers who belongs to the science background and also from the mathematics background. Maybe you do have knowledge, then help me out in the comment section or the chat section with the same. So the body balance we are achieving it through one of the things available on the backside of this brain, which you are going to answer and help me out, because this particular meeting is should be the interactive one, and you should come up with the questions and any doubts you do have in between. So the inertial system is composed of two things basically in robotics body. First one is the gyroscope, and second one is the accelerometer. So what is gyroscope and what is accelerometer in details? So gyro help us identify the exact location of a body in space. So exact location, how we can able to come up to the conclusion of exact location? We are talking about three of the major axes we already studied in our classroom program. So we are talking about x, y, and z axis, which gives through the gyroscope we can get exact reading of those axes. So we can see the orientation of our object, like the robotics body itself in space, and also it helps us to identify the acceleration in a specific axis. So the inertial system in robotics is composed of gyroscope and acceleration. Some of the cool example which I'm going to show you after this one. The gyroscope in common whenever you are going to use in your robotics classes is MPU 6050, and the ADXL module is used to is one of the accelerometer available in the market for you to integrate in your robotics project. So apart from this inertial system, what we do have is the audio system in our body. So ear actually helping us to hear out everything. Whatever I'm saying, using my mouth, actually creating some of the through the vocal cord, I'm creating some of the sounds, right? So our ear is helping us to hear those audio signals coming from the other person or from the environment. But in robotics body, we do have microphones to like accommodate the same functionality, and also to gather the information of sound waves coming from the environment. And for taste, what we do have is the taste bud available in our tongue, right? So in robotics, there is no such things to identify different taste, because if we try the food from different person, maybe the same noodles or same ingredients, the same noodles or same food will be different in taste because of different ingredients placed by the common different persons, right? So there is one of the things we should consider. I'm referring to the humidity sensor by the term taste recognition in our body. The humidity sensor means it is helping. The humidity sensor helps us to identify the exact moisture content present in the environment. So through that, we can able to design such a cold storage space or any of the hatchery projects, so that we can accommodate the humidity sensor and we'll get the reading of moisture content in the atmosphere. So fluids are being transmitted in our body or like circulated in our body using veins and arteries available connected directly to our heart, right? So in robotics body, we do not have veins and arteries, but yes, the pipes to like flow those fluids, like the pneumatic, like the fluids which help us to move body parts in robotics to produce certain motion. Because maybe you know or don't know, let me tell you one thing in between. So we do have two of the systems to control the three of the system basically to control the movement in robotics body. First one is the pneumatic system which is being used in different industrial robotics. And second one is the hydraulic system. Maybe you heard this term before, I believe. And third one is the electronic system using the electromagnet or something like that. So pneumatic system deals with the air pressure. So if we are controlling any of the parts and if we are producing motion in any of the parts of robotics using the air pressure, then we call those motion producing element as pneumatic element. And also if we trying to produce the motion using the oil pressure or fluid pressure, then we will call those system as hydraulic system. And further, in common in our classroom program or in the STEM subject, the time when you will cover the STEM subject in your classroom program, you will always go through the electromagnetic or electric system in between, because the motors and different actuators are totally relied on electromagnetic induction principle. So we will produce the motion from the electric signal in our robotics body. For now, we are not going to utilize the pneumatic or hydraulic system in our classroom program because it is too complicated for a teacher and also for the students to understand the concept. But yes, obviously as a teacher we should know more about these systems, because if any of the student will come and ask how the JCB operates without the motors and all, then you should mention those machines are composed of pneumatic and hydraulic system, and it works principle of the air pressure and the fluid pressure. So micro pumps actually implemented in robotics body to help sorry, micro pumps are actually helping robotics body to help us achieve those things like the pressure difference in between the systems to produce the motion. So for the speech, what we do have is the vocal cord, and in robotics, what we do have is the micro speakers, or normally these speakers itself to produce the sound outputs. And also to determine the pressure, what we do have is our skin itself. Skin serves both of the purposes to sense the pressure and also to get the sense of touch from other person or anything around us. So we do have different kind of pressure sensor, because suppose if you are building one of the student from the one of the student who were integrated like worked with ISRO team earlier, I believe in 2014 or 2015, made one of the smaller satellite, that is CubeSat. So whenever you are sending some of the robotic system with using the helium balloon or something like that into the space, then you must consider these type of sensor, the pressure sensors as well, because you have to monitor the pressures point, or the pressure have coming to the whole body itself. Then only you can able to come up to the conclusion where you will design such a system to resist those pressure. And also if you are going to make the amphibious robot, you should consider the pressure sensor in between, because underwater it will always be like the more pressure, the deeper you will go inside the river or the sea, the pressure will be drastically increased, right? So you must consider these sensor while developing the project. And the reason why I'm mentioning these terms to you in this classroom program, because the time we don't know which type of project we are going to build in future, right? Suppose if one of the student is going to participate in competition and the problem statement is something like this, to make a robot which can travel up to that much of height, or inside of the which can travel inside of the ocean at this much of height or this much of depth, then you should consider these terms to like address the issue. Means if you need to gather the information about the moisture content, then you should utilize the humidity sensor in your project, right? And if you have to take the readings of the temperature in the environment, then you should consider the temperature sensor. So similarly, for different purposes, we do have different set of sensors to address the problems, right? So in our body, we do have nose to identify different smells and fragrance around. And in robotics, we do have different gas sensors. And gas sensors means we can accommodate this gas sensor to detect the presence of different gases in our environment. And by the term different gases, I mean the CO2, the different composition of C and O, carbon and oxygen in the air in terms of carbon monoxide or carbon dioxide, and different composition of nitrogen and oxides. So that is NOx. Maybe it will be the nitrogen oxide or nitrogen monoxide or nitrogen dioxide or nitrogen trioxide, and the content of sulfur oxides. As well as we can able to detect different alcohol. The same thing, the breath detector, I believe you have maybe seen those examples of that device. The traffic police were utilizing in their application to detect the person who, whether the person is drunk or not, right? To identify the presence of alcohol content in our smell or the in our breath. So they are actually utilizing those sensor to identify the amount of alcohol intake, and also we can able to build a system to prevent the major accident happening because of that. So suppose if you are building one of the smart helmet in your classroom program, then you should accommodate the alcohol sensor nearby to the mouth area, as well as the retina scanner or something like that, the IR sensor to monitor the blink of our eyes. Because sometimes we often seen that truck driver gets sleep or while driving the truck or something like that. So because of that, many accident happens in day-to-day life. So we can able to prevent that as a teacher, because you are not the teacher, you are not the teacher, you are the innovators of tomorrow. Because of you only, the student are going to innovate something in their classroom program, right? And through the STEM education and robotics education, we are helping them to build a good career in this domain, right? So you will be responsible to help them understand the concept by giving them the example of simple stuff in your classroom program. So after that, what we do have is the touch sensor. And why to have touch sensor in robotics body? Because in some places you cannot accommodate the actual buttons, or because it is old fashioned, we can say it is old fashioned, but some of the places we cannot able to accommodate the buttons because it might get in touch with the water or something like that, the erosion causing agent or something like that, and it won't work for a long period of time. So that is why the touch sensor is very much important for you to learn and accommodate, and also to accommodate in the project itself for them to understand the concept. So maybe you already seen the example of touch sensor in your mobile phone. Earlier times we used, there are two types of touch sensor actually present in the market. So, okay, let me reduce the size of the screen. Yeah. So there are two types of touch sensor present in the market. One is the resistive type. Resistive type means it does have a sandwich of two layers. So whenever a user presses the upper layer, it get in touch with the bottom layer, and further it helps the microcontroller to understand which part of the screen has been touched. So it will help the microcontroller to understand that there are some input is coming from the touch side. But apart from this resistive type of touch screen, in nowadays, we do have our mobile phone accommodated with capacitive type of touch screen. Capacitive type of touch screen only requires the capacitance of 2 points. Capacitance of 2 points means whenever you will bring a conducting medium like the hand or finger or the skin, then only it will work. Otherwise, it won't work. So capacitive means it will take the capacitance of 2 points, and it will help the brain to understand that this particular part of this screen has been touched or depressed. So even though some of the touch type of buttons is already available in the market, you can buy those to help the student understand the concept of touch sensors, and also you can accommodate those things in your project as well further. So why we do need the sensors in different systems? Because sensors, as I mentioned earlier, the sensor is the thing which help us gather the data from the environment, right? So sensor, actually, if we take the example of this aircraft which is flying in the air autopilot mode, so sensor actually determining the position, height, speed, temperature, and location. So and then it is sending this signal back to the computer system in terms of, okay, you have to understand the concept of two things in between: the microcontroller and microprocessor. So what is the key difference between microcontroller and microprocessor? Anyone do have any idea about the key difference between microcontroller and microprocessor? So you can unmute yourself, or you can ping the answer in the chat section if you do have idea about the microcontroller and microprocessor system. That will be a great addition into this classroom program by directly interacting with me to resolve the issues or the doubts you do have. So anyone do have idea about the difference between microcontroller and microprocessor? Yeah,
Yes, sir.
please go ahead.
Yeah. Microcontroller is a device that I put my code there.
Yeah.
Yeah. I write there the many instructions and many something like this.
Yeah, that's
Microprocessor, the way the device where I process
yeah.
my instruction.
Okay, that's great addition to this classroom program. Let me clear this doubt for all of the teachers out there or mentors out there. So we do have two specific terms like the microprocessor and the microcontroller, right? So what is the key difference between microcontroller and microprocessor? Let me tell you. So both of the things are actually same. Okay, the same means it is completely same, but a little bit difference is there in between. The microcontroller does have the capability to do the higher calculation, or we can say that those processors which are capable to do much more calculation are termed as microprocessor. Okay, so microprocessor, you will often find microprocessor is placed in your computer itself, in your mobile phone, in your computer, where there are plentiful of tasks are there running in the background. And also you in simultaneously, if you are playing the video and listening, hearing out the sound coming from the mobile, so there are much more complication in processing in there, right? So on that place we need to use the microprocessor. Okay, so even though some of the development boards which we are going to use in our classroom program will be the Arduino boards or the Raspberry Pi. So Arduino board is itself, we can call those things as microcontroller, because microcontroller does have a limitation of calculation as well as the storage size. If storage size, so if you take these, if you go through the Google and search for these two terms, then you will find the difference. The microcontroller are very small computers, we can say, and it does not require that much of like potential or the power to run, and also it can be accommodated in the small spaces, and it does not require that much of electronic to perform the logical outcomes. So microprocessor, on other hand, does require like motherboard and kind of stuff, which is available in our computer as well as in our mobile phone to process the data separately. Means if we have to generate the sound, then we need a sound IC or integrated circuit to perform the same. And also if we need the video output, so we have to integrate the video like converter or something like that, the IC in between, along with the microprocessor. So microcontroller is the small computer, we can say, and microcontroller is a small computer, we can say, and microprocessor is the processor itself which does the higher calculation. So in aeroplane and rocketry system, we often use the microprocessor. Okay. And in robotic system, for to do the small calculations and the small logical output production, we use the microcontroller in between. But if you take the example of Raspberry Pi, that thing is also one of the microprocessor integrated into it, because in Raspberry Pi we can accommodate the sound system, we can accommodate the display module directly without utilizing any other device. But in microcontroller, we have to utilize a mediator in between to run each and every devices. Even though to operate a normal motor, you have to integrate the motor driver in the microcontroller to make it functional, because microcontroller often produces 0 to 5 volt as an output. I will explain you this in a minute. So we actually took the example of the aeroplane and the sensor actually determining the position, height, speed, temperature, and location, and further sends those things to the computer, and computer processes the data based on the programming done into the computer system, and further produces the output. And output in terms of the aeroplane itself, the aircraft itself, will be the in engine we are talking about the speed consideration, and the RPM of the turbines and all of this stuff. And the flaps is used to maintain the altitude, and even though to land the aircraft on the land, and also to go for the higher heights. So the motor is also implemented, the wings is also responsible to produce the output in aircraft system. So let me go further in this chapter. Okay. Okay. So yes. So we were in the term where I was defining the sensors in between. So sensor, basically we can call the sensor as to detect the quantifiable physical, chemical, or biological property, or to convert the readable signals such as electrical signals to produce the output information for the microcontroller. So we can call the sensor as input device for our microcontroller, through which microcontroller gather the information of the surrounding. Means through the sensor itself, microcontroller understands what is happening in the surrounding, and further it processes that data and produces the output based on the logic we place through the programming inside of it. So let me show you some of the cool example of sensors which we are going to utilize in our classroom program, as well as we can bring many of the devices along to uh, perform the experimentation in between. So we do have, you can see the screen, right? So it does have different type of sensors available in this screen. Yeah. Lata ma'am said in the chat section, microcontrollers are designed for a specific task, while microprocessors are used for larger and general purpose processing. Yes, ma'am. That's great answer. Actually, yes, this is the right answer you mentioned. Thank you so much for sharing your answer. Microcontrollers, yes, are designed for a specific task. Suppose if we have to do the automation in our door or something like that, whenever a known person will come in front of our home or the house itself, and the door must be unlocked or the door will be opened, something like that, means we can utilize the microcontroller to perform that task for single purpose or two or three purpose in between. But microprocessors, on other hand, are responsible for larger and general purpose processing. So we can see different type of microprocessor are present in our computer system, and those comes in a different varieties, right? You see in the processor type and generation, the i3 generation, i5 generation, i7 generation, those only the higher the generation, it increases the calculation speed and the number of tasks can be executed in the same time. That how we are calling different generation of microprocessor are. So you can see different images of sensors available in the screen itself. There are variety of sensors present. Okay, let me zoom out a little bit so that I can bring my toolbox. Okay, fine. Great. So we do have color sensor to detect a specific color from the environment, and Amazon warehouse actually utilizing these type of sensor in sorting out the boxes of different colors for different places. So color sensors can be accommodated in any of the robotics project to identify the color of a specific object in front of it. And after this, what we do have alcohol sensor. As I mentioned, alcohol sensors are used to identify the alcohol present in the air or like the breath itself. Like I mentioned one of the example to utilize the alcohol sensor in between, right? So the alcohol sensor, and for to detect different type of gases present in the atmosphere, we do have different type of gas sensors, or we can call it as the smoke sensor itself. So different gases means, suppose if you are building one of the application, one of the project in which you have to detect the presence of LPG leakage. LPG leakage, and we all know as a teacher, the LPG does not have any odor or any smell in it, right? We always mix the ethyl mercaptan into the LPG to let the LPG have those fragrance or smell come. So to identify those things, we can accommodate the gas sensor in our project. And also, you can see one of the things are mentioned in this picture, the LDR itself. Yes, some of the people, there are counter argument in this topic, that some of the peoples consider the LDR as sensor, but in my point of view, the LDR is not the sensor, but a simple electronic component, because LDR stands for light dependent register. So whenever light falls into this particular component, the LDR itself, what happens? The resistance increases. Okay, so it works like that. So it will be resistance of this LDR will be changed based on the incoming light from the environment. So apart from this LDR, what we do have is the thermistor or the temperature sensor to sense the temperature. And now, okay, recall that particular concept which I taught just earlier in this classroom program. I mentioned two of the things, right? Digital system and analog system. Now you will understand why we need to have these two systems, digital system and analog system. So suppose if we are talking uh, about the color sensor. So if color is red, suppose we are detecting the color red from the sensor, then what will happen? If the color of the box in front of the robotics device is red, then what will happen? It will produce the value 1. If it is not red, then it will produce the value of 0, right? Using the digital system. But why we need to have the analog system? Because temperature sensor and temperature will not is not a constant value, right? Not the zero, nor not the 0 or the 1. So it does require analog type of output as well as input to gather the information, like temperature from the environment, or we can say that the intensity of light using the phototransistor available in here. The intensity of light can be detected using the phototransistor. And also, uh, the analog system can be used in these type of sensors. So we must understand the concept of analog and digital to like strengthen our programming skills, because the time when you will do programming for these parts, you must accommodate your program with the proper analog input and analog and digital inputs and analog and digital outputs in your programming part. Otherwise, what will happen? You will get different readings, which will be not good for your project development. So apart from this, what we do have is the PIR sensor, and PIR sensor stands for, or the PIR stands for passive infrared sensor. And you will find these the application of this particular sensor in, I believe, different environments. The security system available in your home itself, the motion sensors, different cameras which activates itself based on the motions, works with the PIR sensor is integrated on those type of cameras and system to detect the motion in front of it. So we can use the PIR sensor, and there will be one question for you teachers out there to find out the exact thing on top of it. The white thing you can see, my question is, which type of lens is there in this PIR sensor? Because obviously we are actually detecting the movement in front of it, then we must need some of the lenses in front of it, right? So you have to find out the answer of this question afterward. So IR receiver is one of the sensor available in the market which can, yes, yes ma'am, please go ahead. Rance ma'am, you raised your hand, right? Ransford Nana Ado Asare. Okay, fine. Let me know if you do have any question in between. I love to answer. So, okay. So IR sensor is one of the sensors which is based on infrared radiation. And we already know about the term infrared because it comes into the light spectrum, right? So it works on the infrared radiation, but yes, whenever you are going to utilize the sensors in your project, you must know the application of that sensor and also the limitations of those sensors. Because if we talk about the IR sensor itself, then what will happen? The IR sensor works with the infrared radiation, right? So whenever we expose the IR sensor to the sunlight, then sunlight also consists of the infrared radiation spectrum, right? So what will happen? It will start receiving those signals from the environment compared to our requirement for the project. So you must take care of the limitation of different sensors in your project. So apart from these, what we do have the IR receiver and a different type of IR emitter as well, known as IR sensor, the transmittive type, and other one is the reflective type, which we will discuss while doing the practical project. And also you can see one of the example of touch sensor is mentioned in this picture. The rain sensor to detect the presence of rain, and heartbeat sensor is nowadays very much popular too, because it is placed in each and every wristwatch or the digital watch we do have. And after this, what we do have is the ultrasonic sensor. Ultrasonic sensor is based on ultrasonic frequency. Like the animal bats can detect the obstacle without having an eye, using the ultrasonic frequency and echolocation. The ultrasonic sensor is designed in such a way that one of the eye transmits the ultrasonic frequency and other one receives that ultrasonic frequency upon reflection from the obstacle present in front of it. So we can accommodate ultrasonic sensor in place of IR sensor, where we are going to expose our project to the sunlight or something like that to detect the presence of obstacle in front of us. So soil moisture is one of the greatest examples present in the sensor modules. And also I love to utilize this sensor to identify the soil moisture content in soil. And through this sensor, you can actually make one device which will water your plant uh, based on the requirement of water in it. So you don't have to water your plant on daily basis. We can accommodate this type of sensor in our pots, and further the brain will process the data. If the moisture level drops below 40% or 30%, we'll do the programming stuff to like figure out the same statement to solve this problem. So soil moisture sensor will detect the presence of soil, and further brain will decide if the moisture goes below the 30%, then brain will decide to water the plant. So it will automatically execute the water pump. You will find different water pumps as an output device present in the market. The smaller one which runs on the 5 volt or 12 volt something, and I will help you understand the concept of that voltage potentials and how to like determine different voltage and how to identify different things in the output device as well. So using this moisture soil moisture sensor, you can build one of the project to like the self-watering plant or same self-watering system in your home as well as for your school. And also a student can come up with the idea to implement different things using this sensor. Okay, fine. So I hope the doubts related to the sensors is clear, right? If anyone do have any type of doubts related to sensor and anything, then let me know by raising your hand and dropping your question in the chat section so that I can answer those simultaneously while delivering that particular topic. So you can see the spectrum of sensors. We do have different varieties of sensor like the infrared sensors, level sensors, gyroscopic sensors, acceleration sensors, pressure sensors, temperature sensors, and chemical, motion, proximity, image, optical, water quality, and smoke sensors. So how we can classify those sensors based on our requirement, that is the main point to consider while working with any type of sensors. Okay, so there are basically two type of sensor present in the market. If we talk in terms of the passive and active type of sensor, we can call that passive and active type of sensor to like gather the information from the environment, right? So passive type of sensor are those sensor which relies on the input coming from the environment. So if we talk about flame sensor or IR receiver, then we can say that we are we are being dependent on the information coming from the environment, right? So those sensors will be termed as passive sensor, which are required to gather the information from the environment directly. And the second type of sensors are active type of sensor, which produces its own signal and further receives its whenever that signal comes back from the reflection from the obstacle itself. So those type of sensor will be termed as active type of sensors. Okay. So after that, we do have is the difference between the analog and digital system based like with respect to the sensor itself. You can see several examples are there. The humidity sensor, or we can say that some of the sensors are the digital ones as well as the analog ones, means we can utilize these type of sensor like ST12D or something like that for both purposes, like to get the information in term of digital and in term of analog system. Suppose if any of the moisture content is present in the atmosphere, then it will produce the value 1, and if it is not present, then it will produce the value 0. The gyroscopic cover, the sensors like this one are termed as digital type of sensors, and these type of things are termed as the analog type of sensor, which depends on analog type of input and output system. So joystick is one of the example of analog system I mentioned earlier as well. Piezoelectric speakers, which can produce electricity upon like motion or any vibration present in the environment itself. And also some of the transistor which is directly responsible to generate the temperature uh, temperature point for us to consider in our programming part. So this is all about the sensor and other stuff. Let me show you some of the examples. So you can see as you will have the LMS access after this class, so you can also go through the entire content, the theoretical portion, and it will be helpful for me to cover up the practical part in this journey, and it will be useful and helpful for you guys to understand the concept. So go through the theoretical content once, and let me do the practical part in front of you. So, okay. So the basic system of robotics, after the sensor, what we do have is the brain itself, right? So you may heard of different type of brains like the Arduino boards. You can see there are plenty of boards present in the market. So basic boards are the Arduino Nano or Mini or Arduino Uno boards, and the enhanced board is the Mega one, which does have more pins in which we can accommodate a large number of input and output devices. There is one difference only, the connectivity option, uh, and also the connectivity option and the number of pins available for input and output devices. So the IoT boards are also available in the market, and one of the IoT board which I love doing the work with is Node MCU or ESP8266, which does have the Wi-Fi capability inbuilt into it. But instead of utilizing the IoT board, if you go with the any specific board like the Arduino Uno or the Arduino Nano models, then you will find yourself in a position where you have to utilize a mediator in between. Like if you have to communicate with other devices in front of it, then either you have to use the wire connection or the Bluetooth connection or Wi-Fi connection. To do that, in the basic boards, you have to accommodate the modules, the Wi-Fi modules and other stuff, the Bluetooth module. And by the term Bluetooth module, I meant to the SC05 SC05 modules. So these will be like additional things to be added into our microcontroller and the board itself. And by the term microcontroller, I'm not meaning the microcontroller. The Arduino board is not the microcontroller. The Arduino boards are the development boards. Okay, you have to understand the difference between the development boards and the microcontroller. So Arduino boards are the development, and any other boards like this one, those each and every boards are the development boards. And inside the development board, we will find these type of ICs, right? So why we do have this type of IC, or this particular IC is known as EEPROMs, and the full form of EEPROM is electronically erasable programmable memories. And these particular EEPROMs, a specific variant of IC's integrated circuit, is the microcontroller. Okay, so you have to understand the difference between microcontroller and development boards. So those boards which does have the microcontroller embedded into it, and through which we can like utilize the pins directly for our purpose, either to take the inputs from the environment using sensors, and also to produce the output from for the different output devices. We can accommodate those things in here in these pins, right? These are the IO pins, input and output pins. So microcontroller is the IC placed on the development board, and this particular IC is at mega 328. Maybe the variant will be PU and PU depending on the model you are utilizing. So the manufacturer of microcontroller is Atmel, and the chipset name of the chipset is Atmega 328 P or U or PU variants. So this one is the EEPROMs and the microcontroller itself, and the combination of microcontroller and bridge IC, which I will explain you in our next classes as well in details, so that it will be easier for you to understand the whole concept. Otherwise, what will happen, you will be dependent on these boards in your future projects, and I personally don't want you to be dependent on these boards directly. You should come up to the idea where you can utilize the microcontroller directly in your project. Then only you will save the money buying these high priced products from the market, and also you can accommodate your electronics in such a small space for your project, so that your project will be perfectly good, both in terms of aesthetics as well as the functionality part. So this is all about the microcontrollers and the development boards. So let's move further in the another basic component of robot, that is command, which is our crucial part to discuss in this segment of lectures. So commands is basically a piece of program. We call it as piece of program or set of instruction. Program itself known as set of instructions to given to a machine or a hardware devices to perform its duty or task, right? So by the term command, if you look into the picture, actually we one girl is guiding the dog to like perform the task in front of it. And similarly, if we give the similarity of command, then we are producing the same event using the block diagrams, or we can call it as scratch programming in general. So maybe you already heard in STEM concept that you must utilize the scratch programming as well as the embedded C++ programming, and also for higher classes we should go for the Python programming. That is very crucial. And in all 24 series of lectures, we are going to cover each and every topic in details. We will start with the scratch programming, we will go further with the embedded C++, and we will end the session with Python programming by giving some of the examples, and also to integrate the hardware device directly into the programming itself. So in this programming part, you can see whenever a space button is pressed or a space key is pressed, then what will happen? It will repeat this complete syntax, right? It will rotate the things or the object in clockwise direction at 30 degrees. It will wait for 1 second, and it will again rotate the things or object in front of it at counterclockwise 30 degrees, and again wait for 30 seconds, and this cycle will be repeated. We call these cycles in our programming as forever. In terms of scratch programming, we call it as forever, or in terms of embedded C programming, we call it as loop. So you must remember these terms, because we are going to utilize these in our next 3 of the classes. So loop we are going to use in Arduino IDE, which is a best platform to utilize your embedded knowledge and to integrate the project into the hardware devices. So okay, so what we do have for the programming is the different type of platform. So we are going to utilize the Tinkercad simulator. In Tinkercad simulator, actually the Tinkercad platform itself is an open source platform, as you know. So open source platform gives us the ability to utilize their tool freely without paying any of the money, right? So I will guide you throughout the journey to perform the scratch level programming in Tinkercad platform. And also you will learn the concept of embedded C++ first in Tinkercad platform, and further we'll go for the embedded C programming in Arduino IDE or development environment. So you can see one of the examples where we accommodated the Arduino with our servo motors, right? And servo motors, actually we are guiding the servo motor to perform certain tasks. So actually I'm showing you the screen view of the Tinkercad platform for you to understand. And for the next class, I request each and every teachers to sign up for that platform, Tinkercad platform. If you want to take this screenshot, you can take this screenshot and sign up for the same, so that you can also parallelly utilize the platform with me the time when I will teaching those things to you. So it can be accessed using internet, and you can utilize any computers, any laptops, regardless of the configuration, to operate the platform. So we do have some pros and cons to like develop the things in Tinkercad platform. So it does have very easy. So it does have very easy interface for the teachers and the students to work with, because it does have drag and drop interface for creating and simulating electronic circuits. So comes with a wide range of components such as a resistor, capacitor, and diodes. So if I open up the Tinkercad platform for you, then okay, let me open up the Tinkercad platform for you teachers. So if I click on design and create, we do have three of the options: circuit, 3D design, and code block. For now, I will go to the circuit option, and you will find plenty full of examples of different components are there available in the right hand side: the LED, register, push button, capacitor. So if I have to work with Arduino, then I will search Arduino Uno or Arduino simply. So it will help me like drag and drop the Arduino board directly into my screen. And further, we can utilize any of the wire to connect any of the electronic component directly with the board itself. Suppose if we have to integrate the LED, okay. Suppose if we have to integrate the LED into it, then what we will do, we'll drag and drop the LED and directly connect the wire of different pins to the terminal of LED. So through this, I believe the student will learn the concept in a very fast and the very speedy manner. And further, you teachers can be involved in doing the simulation before going to the practical projects in your classroom program, because these devices comes at a price, right? And if somehow you damage the student will damage these devices, then you have to reacquire it from the market, and that is not a good idea to buy the component or the product again and again. So you must go through the simulation part first with yourself, for yourself, the time you are learning the concept, and same you perform in your classroom program for the student to help them understand the concept first in the simulation platform, and further they can go for the practical work directly with the Arduino boards. So here is the overall concept of the Tinkercad platform. It does have like different, it does supports different third-party plugins for extending its functionality, and also users allow users to collaborate and share their projects with others. Suppose if I'm working in any of the project, and I will share you the classroom link at the end of this session today, so that you can also join over this classroom link and further share your project with me, so that I can exactly troubleshoot the problems you are facing while building anything. Suppose if you're working in circuitry, then I can see those circuitry from my windows as well, from my account, and further we can come up to the troubleshooting part. So okay, apart from the Tinkercad platform, what we do have is the Arduino IDE. And Arduino IDE, or the development environment, integrated development environment provided by the Arduino itself. And you know, Arduino is one of the open source platform itself, right? So like this other software we do have in our computer system, the Arduino interface is approximately similar to other softwares. So it does have the menu bar on the upside, and it does have the toolbar button and also the text editor for writing the code. Here you can see the IDE version and the file name of your project in here, and also the menu bar is on the top side. And if you click on any of the menu bar, you will get the drop down menu. That is the common convention to address any of the software present in your computer, right? So here this blue bar will show you the uploading status or the status you are doing in the IDE itself. And in case if you get any error message or any other messages coming from the compiler, you can see those things in the black portion in here. And on the bottom side, on left and bottom side, we can see the configured board and serial port. On the right hand side, it will show the configuration of the board we are utilizing with the IDE itself. So I'm going to show that in a minute because we are going to perform some of the practical work as well today. So, okay, let me clear up these things like the IDE and Tinkercad simulators. So Tinkercad does have a user friendliness environment where user can like collaborate and share their project with others, and it does have the inbuilt examples and also the inbuilt library for different components. So you can directly drag and drop different components from the menu bar or from the tool menu. So if we go back to this chapter, let me see how much it is completed. Okay, so let's discuss the type of robot, and after the type of robot, after 5 minutes, we'll go back to the practical project. If you teachers do have the Arduino board with you, then I recommend bring those things on your table so that we can do the experiment parallelly. Okay, so we have to consider the types of robot as well in our STEM classes because there are many varieties of robot present in the world, right? So we have to differentiate them based on the kinds and activity they perform. So we classify the robots in different categories like the autonomous mobile robots or AMRs, and automated guided vehicles, AGVs, articulated robots, and humanoid cobots and hybrid one. So what is the key difference between all of this? Let me give you the definition and we'll move into the practical project. So autonomous mobile robot means a robot which is capable to move autonomously from one place to another without a guided path, like the car itself. You've seen several examples of Tesla cars and other examples of different vehicles present in the market, which drives itself without any guided path, like on line mark or something in the pathways itself. So those will be termed as autonomous mobile robots, AMRs. And what is automated guided vehicles, AGVs? What AGVs moves through an environment following a guided path. Maybe K author is requesting to record this meeting locally. Okay, you don't have to worry about the recordings because I will personally share these recordings with you, teacher. And also in our platform, if you search in YouTube X Robotics, then you will find our channel where this particular video will be published in a like after the completion of this classroom program today. Okay, you don't have to worry about anything. I will also share you the notes and specific details because as sir I already mentioned to you that you all are going to have uh, the LMS access, the learning management system access for the same. So each and everything, the theoretical portion will be there. You can go through the theoretical portion, and in case of doubt, just come to me and ask me the question like 1,000 times. If you ask 1,000 questions in between, there is no issue on that. I just want to deliver an interactive session with you teachers because you hold the same position as I do, right? So you are perfect in your profession, and I love to communicate with you guys and come up and take your suggestions and improvements to further improve this entire journey, right? So AGP, let's move back to this topic and complete this topic so that we can directly jump into the practical part. So AGVs moves through an environment following a guided path. So maybe you already seen some of the examples of line following robots and the robots in warehouse which follows the line and specific signals present in the environment itself. So those will be termed as automated guided vehicles which need some of the guidance to move from one place to another. And what is the articulated robots? So articulated robots does have a more number of degree of freedom. So what is degree of freedom in between? So degree of freedom is something. Okay, author, sorry for the delay. I just come now, so the recording will be available. Yes, sir. Absolutely, the recording will be available. You don't have to worry about anything. Okay. So the articulated robot is something does have like rotary joint that often resembles a human being, because as a human being we can produce many motions with our one of the parts, right? Because we do have a more number of degree of freedoms. And by the term degree of freedom, I mean, suppose if you do have two of the joints, suppose I do have this particular joint and this is connected to another link like this, then we can only able to rotate this link in this direction, in the up direction or in the down direction, only two of the directions. So we call this link as 2 degree of freedom, or like because we can able to rotate this in two direction. Okay, so we'll call it as 2 degree of freedom. So I will explain the degree of freedom in details in our upcoming classes. You don't have to worry. So similarly, the articulated robots does have more number of degree of freedom because it does have a mechanism inbuilt which resembles a human arm. So more likely you will see these type of robot present in the industry where automations and the automatic welding of cars take place in the industry. So humanoid is one of the type of robots which resembles humans, also called as android. And you may be seen Sophia and other kind of robot which actually looks like a human being, right? So those robots, we will call those robots as humanoids. So cobots, on the other hand, we do have is intended for direct interaction with human within a shared place. Within a shared place, you have to consider this particular line at the ending. So maybe you are seen some of the kiosk machine nearby the ATMs or other things, right? If we give the moving if we somehow provide the motion to those kiosk machine, then we can call those thing as cobots. Means it is intended for direct interactions with human beings. So it will interact with human being within a shared space. It won't leave this space until and unless we program it to do so. So hybrid robot is consists of both electronic and biological elements, because we have to accommodate some of the electronics into the biological element. If we take the example, uh, hybrids, we can call it as the reptiles kind of stuff, snake like of robots, or they can move from one place to another without any difficulties, or they can go through the different type of terrains according to the need of the uh, time. So these are the type of robots you should consider teaching those concept to your student. And okay, so you as a teacher go through the theoretical content and let me know in my next class, which if you in case you do have any doubts, because next class I'm going to have a completely hands-on session with Arduino boards, and we will also cover some of the great projects and idea also in this classroom program, and we'll finalize these sessions on day 4 with conclusion part. The final assessment will be there for you teachers, so that I can get the understanding how much you learned throughout the session. And also we'll try to bring some of the competition for you to like submit into the Tinkercad platform and that platform. Let's do one of the experiment with Arduino. I believe each and everyone does know about the Arduino platform, right? So let me share my screen of Arduino. Okay, let me show you first the project I built earlier in different platforms. So these are the project I built earlier in one of the major platform. If you utilize WalkV in your project development, then you will find you can write the program on the left hand side, and further you can process that program onto the right hand side directly in the window itself. So if I execute this simulation, okay, it is giving me one error. So let's move back to the other program I built earlier. So if I play this one, so this one is the game console. I seen this game stuff over internet and I tried building it from my own. So if you click this button, you can see the display, LED display actually showing us the value. And those other two buttons are used to control the direction of the moving of. Okay, so through this, we can do the programming for the game console in our project development. So I'm stopping this simulation. Further, I will move back to the Arduino IDE. So today I will cover the simple program for you teachers so that it will be. Okay, Mr. Ponraz Chinmadar said, okay, So I don't have any tools where can I get? So you can buy it online, or you can contact the X Robotics team for the same. They will provide you the insight of how to gather those components. There is no issue. There is a plentiful of things available on the market, but make sure to buy the genuine product from the market. Otherwise, you will end up with losing the Arduino boards and other things, because many Chinese varieties are available in the market. So make sure you are buy a good one. So, okay, I'm sharing my screen with you, the Arduino one. Okay, this one is the IDE which I showed you earlier. Okay, let me turn off my camera in here so that I can show you the hardware part as well directly into the system. Okay, let me remove my virtual background so that it will be clearly visible for you teachers. So I hope this screen is visible to all of you, right? Yeah, sure, Mr. Ponraj. I will definitely love to help you out. Just drop me a message in the group itself. I'm also in the group. I'm available in the group itself. So I will help you out on buying these components from the market or from anywhere else. Okay. Okay. So, okay, my camera is not working. Let me see. Okay, fine. Now my camera is working, right? It is visible to everyone. Is it visible? Okay.
Yes, sir.
Thank you. Thank you for the confirmation. So yes, so this is the Arduino IDE which I showed you earlier in the LMS portal, and it looks like the same, right? So it does have the menu bar, and as I mentioned earlier, if you click on any of the menu bar option, you will find several drop-down menus, right? So in common, what we can say, these menu bars can be used to call different sub-menus item and further to change the value. So we will start with the simple stuff today so that it will be easier for you to cope up with the same. Okay. So if I click on the tools, first of all, I won't start with the file option because it is completely similar to the other application installed in your computer, right? It does have new, open, recent, sketchbook, examples, and close, save as, page setup, and so many other stuff. The preferences itself. So I will start with tools option, where you must consider this thing on first basis. Okay. So whenever you start the Arduino, make sure that board will be chosen properly. So in my case, because I do utilize lots of board in my daily life, so that is why the ESP32, ESP8266, and mini core are available in here. But in general, if you install the program for the first time, then you will find the Arduino AVR board is already only mentioned in your IDE. So choose the board wisely. So right now I'm utilizing one of my board, that is Arduino Uno. Okay, so I place the Arduino Uno in proper case because this one is the original Arduino Uno. I purchased it. So click on the Arduino Uno, and the time you click on Arduino Uno, it will not show you any port, right? So the time when I connect the Arduino Uno to my computer, let me plug in the USB cable to my computer. So you can see the light is blinking in this one. The green one is the power LED, and other one is the onboard LED placed in the IDE. So the time I plugged in the Arduino, again, if I go back to the tools and port, you will find it is showing me the option that COM port 18, the communication port 18, the Arduino Uno is connected. So I will click on it. And the time when I click on it, so you will see that one tick mark is appeared in front of it, right? So you don't have to click and change any other parameters in here. You just have to consider the board as well as the port. You just have to consider the same. Make sure you are using the right board for your program upload. Otherwise, it will contradict with the same. Okay. So right now I'm utilizing the Arduino board, and also I do have one of the breadboards with me. So I will accommodate some of the electronic component in my breadboard, and I do have series of couples of LED with me, and also I will show you some of the microcontrollers and tool stuff in this programming session, so that it will be helpful for you to understand how to integrate those things. Okay, So now the board has been changed to Arduino Uno, and also the port has been selected. Proper port has been selected, COM port 18, that is communication port. And if you are confused with the term COM, which port, because sometime what will happen, many port will be visible in this section, then you don't have to worry. You just hit enter. Okay, let me share my full screen with you so that whatever the operation I will do, it will be visible to all of you. Okay. So now my complete screen is shared. If I click on a start button, and search for device manager, and I click on it, then device manager will appear in my computer. So under device manager, you will find one of the option that is COM ports, that is COM and LPT. So under COM and LPT, you can clearly see the Arduino Uno is connected to COM port 18, right? The Arduino Uno is connected to COM port 18, because some of the times you won't find that particular word in the port section. Right now it is showing the COM port 18 under bracket Arduino Uno, because this particular microcontroller is the original one. That is why it is showing Arduino Uno. But if you buy some of the Chinese or cheap alternative from the market, then you won't find that option under bracket. So you have to consider the device manager option to perform the same. Okay. So after configuring the COM port and board, the sketch section will look like this. So always start with saving the file first. So I do have different project stored in well. Let's say I'm going to write my first program Arduino. Okay, I'm just giving the name to this particular program, and you can see on the top menu the name of the sketch has been changed, and also in the terminal block you can see the sketch name had to be modified, because it is giving me error because I named it too much. Okay, the length of this file is too much compared to the character limits. Okay, no problem. So let me save as first. Okay. So now there is no issue on that. So make sure to change the name accordingly. So we do have to, whenever you open a new window, click on new window, it will always come up with two of the options, that is void setup and void loop. So either you can remove this option and start writing the code from scratch, but I will suggest you to start with these two setups, which comes beforehand for the operation. So under the setup, because Arduino does have different pins, right? The different IO pins, and IO stands for input and output pins. So under this setup, actually we are calling that function the setup function, because right now my computer is unaware of the pins, the IO pins available in my Arduino, right? The compiler itself is unaware of the pins of Arduino. For specifically, if we talk about the 0 to 13 pin, then we are addressing the pins as input or the output. So we must declare which pin we are going to utilize for which purpose. Yes, ma'am? Okay, fine. So under the setup, we will start writing pin mode to address that particular pin. And suppose if you are going to utilize the pin number 9, so we will write 9 and write down input or output. So right now we are going to utilize the LED in our program. So we will utilize the LED directly into the programming part, and we will write the 9 as output. Or we can use pin number 13, because pin number 13 will give us an ability to see the onboard LED in action. This one, the yellow one LED, is the onboard LED, which is directly connected to pin number 13. So you must consider the onboard LED, because it will give you the ability to directly check the program without integrating any other hardware device into the Arduino. So I'm writing the program for pin number 13 now. So pin mode 13. So as I mentioned earlier, remember the two of the system. So under the loop, so we are calling a loop in here on the sixth line, because we are going to run the program written on the 8th to the next lines, to run it completely on again and again. We are going to run that program again and again under the loop. So void is used to call the functions into the compiler, which addresses the specific action in microcontroller, like the input, controlling the input and output parameters, and the loop section will be considered as to run the program on continuous node. So as I mentioned, we do have two of the system. First one is the digital system and second one is the analog system. Remember? So digital system and analog system. So we will separate those things with two of the columns. So now what we do have digital system. So in digital system, we are talking about 0 and 1s. In analog system, we are talking about the range between 0 to 1, right? So to take the inputs, because both of the system relies on two of the things, right? One is the input and second one is the output stuff. So to perform different tasks like the input and the output, we should consider different parameters or the different statement for the same. So if we have to take input in digital form, then what we will write? We will write digital read, and then under bracket the condition will be there for input. Okay, and for output we have to consider the statement digital write, and under the statement will be followed. And in analog system, to take the input we will write analog read, and to produce the output we will write analog write. Okay, these two things we should consider while following the digital and analog system. For now, the time when I'm starting this lecture series, so I will focus on digital system first because it is easy to handle. We only have to handle two of the aspects, 0 and 1s, right? So in by the term 0, we are talking about the low condition of our programming, and by the term of 1, we are talking about the high condition of high condition in our programming. So we will consider these digital system first, and only we are going for the output in today's session, and further we will see the examples how we can take the inputs and further process the data to produce the output using digital system. The time when we complete the digital input and output system, we will move into the analog input and output system and further see the examples to integrate different sensors and output devices in our programming environment. Okay, so if we have to write down, suppose because we gave this particular thing because we connected the pin number 13 to LED, we are going to connect the pin number 13 to LED. So what we will do, we will write digital write to pin number 13, comma, high, because we are going to produce the value of high. Let me connect the LED directly to the Arduino board so that we can see those things in action. Right now, the LED is continuously glowing and it is not blinking or doing anything, right? So if we plug the board into the Arduino, like the GND and the positive pin, let me show you how it works. Okay, just allow me a second, please. Okay, fine. Nothing is happening right now. So let me upload this program first. So I will click here. We do have in tool section, first to verify the program, second to upload the program, third to open a new program, and fourth to open a program and save the program. So we will just click on verify first before uploading the program to our board to see whether this program does have any of the problems or not. If it is successfully compiles, then we will upload the program to our board to see the thing in action. So it shows the notification area shows done compiling, right? Then we are ready to go, ready to upload the program directly to our board. So we are just click on the upload button and further let's see how it works. So I uploaded the program in the board and you can see the LED is constantly glowing because we are sending the high data. Okay, let me place something in the back side of the board so that it will be clearly visible to all of you. Okay, so right now you can see the LED is constantly glowing because I just sent one of the signal, means we are sending the pin 13 to we are sending high value to pin number 13. If I reduce the value to low, if I change the value to low, then let's see what happens. even though if you do not click on the compile button or verify button, the time when you hit on the upload button, it will compile the sketch first and then further upload the program to the board. So right now, if we are sending the value low to the pin number 13, then what is happening? The LED is turned off. So let's recall the last step, the high step, and upload the program to our board first, and then we will tweak some of the value to blink the LED. We will start our programming lessons with blinking LED, and further we'll achieve certain automation in the same. So we send the value high. Okay, in between, why we need in between, if we have to hold this position for a minute or second, then what we will use? We will use delay counter. And in Arduino embedded C++ or the IDE environment, the Arduino IDE does utilizes the delay in millisecond. Okay, so whenever we use the delay word in the statement, means we are talking about millisecond. And suppose if you have to reduce the value to certain extent, like millisecond or something, so like the microsecond or something, then we will use the delay microseconds. Okay, which I will explain you in throughout the programming lessons. You don't have to worry about anything. So we are actually giving the value of delay of 1 seconds, because the delay function itself talks about the delay value in milliseconds. Okay, so if I go for the digital write again, and I'm writing the value to pin number 13 low, and I'm closing the bracket and ending it with a semicolon, and from the next session it will be more elaborative, means I will explain each and every statement of lines. You don't have to worry about anything. Okay, so I'm giving the delay again to hold that particular low value again to 1 second. So you can use the backslash, double backslash to comment out, to give the comment in your programming, because as a new programming, you should consider commenting each and every lines to make sure that your program can be readable or can be understandable by other students in your classroom program. So I will write, so I'm writing that turning LED on in this state, and further I'm writing, putting a delay of 1 seconds to hold the above position, means it will hold the high position for 1 second, and then again turning the LED off, and further holding 1 second the above position. Okay, so this one is the comment line, and it won't affect our program because it is intended to provide the insight of our program, what we are doing inside of the program. So it won't affect anything in between. You can use multiple comment lines, or you can utilize the backslash or a star button to do the same. This is as Kumar and something like that. So you can end it with the same star and backslash. So it will be counted as the comment line as well. So multiple comment line you can use in the programming environment by giving the backslash and a star in between. So I'm uploading the code to my Arduino board, and let's see what happens. And I will explain you why I mentioned the utilization of Tinkercad platform after this. So you can see the LED is properly blinking because we are actually sending the high value on first instance, and then we are putting one delay to hold that particular value for 1 second. And again, we are reducing the value to low condition and putting a delay again for 1 second. And loop, the function loop itself will run this entire code again and again without interrupting in between. So the next time whenever we upload the program, what happens is it overwrites the value of previous program. So whenever we overwrite or like upload a new fresh program to our microcontroller, it will overwrite the value of the last programming. So the reason why I said to utilize the Tinkercad on the first time for as an open source platform, because okay, let me show you why I mentioned that. Then I will come back with the same. So suppose if I'm teaching something to my students, and students is actually a newbie in this particular field, then what will happen? the student won't able to understand the entire concept, right? So let me show you the rules. So now my Tinkercad platform is ready. In here you can see the screen, right? So if I have to replicate the same example, see, I connected the LED. So what I do, LED does have two of the pins, like the cathodes and the anode one. So the cathode is the negative terminal, right? So we have to place the negative terminal on GND of Arduino. In next class, I will elaborate the Arduino board in detail, so you don't have to worry about anything. Just follow up the lecture series and you will find plentiful of example to control the parameters, okay? So here I connected these the LED same way as you can see on the camera itself. The LED is blinking, right? So if I go to the code and like remove, okay, go to the code and click on blocks, and if I switch back to the text mode, so you can see one of the program is already written into it, which is similar to the program I showed you earlier, right? So if I start the simulation, you can see the same action is happening in the open source platform, which is very much important for you as a teacher to like do the experiment beforehand before going to the practical board, because somehow if you try to connect the wires in a different polarity or different things, your component will be damaged. So make sure you should go for the open source platform first and then come to the practical part using the board directly in your computer. So you will ask me one question: why is there LED built in place of pin number 13 as you programmed it in your IDE before this Tinkercad platform? So the LED underscore built-in is the inbuilt function of Arduino which addresses the pin number 13. Okay, so if we change the parameter from LED underscore built-in to pin number 13, let's see what happened, whether it works or not. So let me stop the simulation first, and I'm just removing the LED underscore built-in and changing the value to pin number 13 and see what happens, whether it works or not. So how many of you are in favor of it will work and how many of you are not in favor of it will work? Okay, so I changed the parameter LED underscore built into pin number 13 on all of the places where that was mentioned earlier. And if I hit on the start simulation, then again, what will happen? Let's see, it is initializing. Okay. Okay, so now it is working perfectly, right? The same thing we done in our IDE as well. So LED underscore built-in is the function. LED underscore built-in is this function inbuilt to the Arduino IDE. So the manufacturer or the creator of Arduino platform and everything came up to the idea that they will utilize one of the LEDs in between on board, so that if user do not have any LEDs or something, then onboard LED you can see in here, onboard LED can be used to address the same issue, to directly experiment with the LED inbuilt into it. And what about these two LEDs? We do have the TX and RX. So the TX stands for the transmission protocol and RX stands for the receiving protocol. Suppose if you are uploading any of the program to our microcontroller, then what will happen? The receiving protocol LED will glow up for a minute or for a second, for a fraction of second, I can say. So if board is communicating back with some of the data, so what will happen? The TX LED will glow. Okay, let me show it to you once how it works. And also I will show you one more function today so that it will be easier for you to understand the concept of Arduino's board. So I'm zooming out this thing and I'm sharing my other screen of IDE, which I shared earlier. So I believe this screen is visible to all of you, right? Okay. Yeah, right now the screen is visible. So if we, under this setup, if we include one of the function that is serial.begin 9600, that will be the speed of our communication with the microcontroller. And similarly, if we okay, home, enter and place. Okay, if I write as similar to different programming languages, maybe you already went through several programming languages earlier. In C programming, we use the print function, right? Printf function, and in Python, normally the print function works to print the data serially. Under the tool option, you will find one of the sub menu option, that is serial monitor, clearly mentioned under the tool option. So if I have to take the readings back from the Arduino board, because that is crucial for you teachers to have the debugging option or taking the feedback from the microcontroller, because sometimes what happens, you connected everything well and in a proper manner, and your program or your project is not working properly, then how you can come up to the point where you can troubleshoot the program or troubleshoot the entire thing. So you must enable this serial monitor function in your program. So whenever you should go for the program, you just mention serial.begin function in between, as will be capital in serial.begin, and the bit rate through which it is communicating will be 9600. And if you ask me why 9600, sort of why there is 9600, let me share my complete screen and show it back the detail. So if I hit the enter button, if I hit the window button, you can see the window option is visible, right? Okay, if I hit the window button and again go to the device manager, and if I go to the port option, if I go to the port option and double click on the Arduino, that is connected to COM port 18, the communication port 18. If I go to the port setting, then you can see the speed of the communication is in bits per second, and that is already set to 9600, right? That is our communication speed with the microcontroller, nothing else. Okay, you don't have to worry about anything, because I will cover each and every parameters in my programming journey, in our programming journey, as well as in this classroom program. Okay, so in case any doubts comes into your mind, then you can free to ask those questions as well in the chat section, or directly unmuting yourself throughout the classroom program. So if I write print.ln, if I write, okay, serial.print, and under the print function, if we write LED is on, the same thing I done to the we done earlier with the backslash option by giving the comment, right? We are just copying this thing up and inserting it in here, right? So if I copy this thing up and insert it under the serial.print function, and again after the delay or after this particular line, if I do the same for the other, let me copy the serial.print function and paste it in here, and if I copy the thing in here and insert it under the double inverted commas, or okay, so you have to change the line. So I will write print.ln as well. So it will always change the line. Otherwise, what will happen? Let's see without ln. Okay. So if I upload the program again to my microcontroller, which is already connected to the COM port 18 in here. So if I upload the same program, okay, sorry, we missed the semicolons. Okay, fine. So if I upload the program, so semicolon is an important aspect in programming, because it signifies the end of line, right? So whenever a particular line is going to end at some point, we should use the semicolon in between. But before and after the calling the functions like the loop and all, there will be no semicolon. It will always start with open curly braces and end it with close curly braces. Okay, so earlier our serial monitor were not showing anything, right? So if I change the port speed to 9600, because we set that speed to 9600, and if we see the output, so you can see it is showing us LEDs on, LEDs off. The same time LED is actually turning on and off in the practical environment. Because of the ln function, it is actually printing the everything in one line. So what we need to do, we need to use other function, that is serial.println on the last line. Last line only, it will be enough. So that what will happen, let me upload the code to the Arduino board first. Then you will see the difference between the serial.print function and serial.println function. So now the program is uploaded. So let's go back to the serial.print serial monitor. So you can see LED is turning LED on, turning the LED off, right? Is appearing in same line. So let's change the upper line as well and insert one of the Allen in here and upload the program to the microcontroller and see the changes. So if I click on the serial monitor, then you can see it will always change the line. So I hope you understood the concept of serial print function, serial monitor in the Arduino IDE, and also the basic aspect of IDE itself and how to configure different boards in Arduino IDE, as well as selecting a proper port in IDE, right? And you can see those things are actually working in real time. The thing we are getting, the response we are getting from the microcontroller is similar to the response we are getting in our serial monitor. So in case your program is not working, your project is not working properly, then what you can do, you can enable the serial monitor function to see whether your program is properly executing in the microcontroller or not, to further troubleshoot the program itself. Okay, fine. I hope you understood the concept. Let me stop share my screen and come back to this screen again. Okay. Okay, hi. So I hope you understood the concept of STEM and robotics in this journey. And also, I hope you understood a few basic concepts in Arduino IDE. In my next class, I will cover the entire configuration of Arduino boards. And I will also show you different type of microcontroller I do have, like the Node MCUs and Raspberry Pis, so that you can also integrate those things into your project work. And in case if you find any good ideas from your side, then yes, I'm totally available to help you out to build those projects and help you out to solve those problems happening in your society, in your school as well. So, and I'm calling this meeting off, and concluded part will be there. So in case anyone do have any of the doubts or any questions, then you can ask now, because I'm going to conclude this session for today. Any questions or any doubts?
Thanks for your effort, but I want to ask about the next session, inshallah, when it will be. And what about the recording? If we can have it, of course.
Yeah. The recording will be shared over the group itself. I will share you the links of the recording in the group itself. You are joined in earlier. And also the next class will be notified directly in the group, ma'am. You don't have to worry about anything. We will keep you posted as we do have your.
Okay, I'm really sorry, but I don't know which group, because I received an email, but I don't know.
Via mail. It will be conveyed by mail to you back. Okay. If we are
Thanks a
going
lot.
to arrange a session, suppose tomorrow or day after tomorrow, mail will be sent to your address so that you can go through the same. And also the recordings and all the links will be shared to the mail. And those people who are in the part of our group, in WhatsApp group, will receive directly from the group itself. Okay. And further,
Thanks
those
a lot.
are enrolled through the email address and so will receive the things from the email itself. Yeah. Miss Annie, thank you so much for the comment. Wonderful session. Thank you. So thank you everyone for joining this session. And remember, because of you only, these kind of session I can organize and I can come up with the ideas to help you out in your endeavors. So thank you thanks to all of you teachers out there and beautiful minds out there. In case of any problem you will face in your life, like the related to project and related to STEM subject, I'm open up for everyone. You can drop me a message and you can drop me a call anytime. I will help you out on those endeavors. Yeah, thank you so much, ma'am. And thank you everyone for this session. Have a good day.